Right. So example 5, find s prime, find the derivative where s is x cubed plus 5 divided by the square root of x. So I notice that the way that s is put together is we have x cubed, and then we're adding 5, and then we're dividing by the square root of x. And you might be saying to yourself, well, Lindsay, we haven't learned quotient rule. We haven't learned what to do with a division symbol here, one function of x divided by another. And we will learn that, but there's a little bit of algebra that we can do here to clean up s, and that'll allow us to use both sum rule and our power rule. Let's do a little algebra. Your function x cubed divided by 5, x cubed plus 5 divided by the square root of x, that is x cubed divided by the square root of x plus 5 divided by the square root of x. I decomposed that fraction. There is no side to equalities, but so often in mathematics we're used to going one way, right? In your algebra class, you're used to going this way. You're saying, oh, I'm adding two fractions. What do I need? I need a common denominator. Ah, I have them. What do? I add my numerators, x cubed plus 5, and write it all over the common denominator. Right? That's the comfortable direction, but there is no side to equalities. Why do I want to decompose this fraction? Because x cubed all over square root of x can be simplified to a power of x. Remember, the square root of x is x to the 1/2 power. So let's do that on each of these. The base of my exponent is the same. I can subtract these exponents. Right? X cubed is x to the 6/2. 6 divided by 2 is 3. X to the 6/2 divided by x to the 1/2 will just be x to the 5/2. Let's do that on the next line, though. And this piece, 5 divided by x to the 1/2 power, is the same thing as 5 times the reciprocal of x to the 1/2 power. Oh, it's 5 times x to the minus 1/2 power. Almost done on the algebra. 6/2 minus 1/2 is 5/2. And now notice how delightful this is for power rule. This is nice for calculus. In algebra, you would have probably preferred to clean things up and write it this way. All right? But now it's in a great form. S is one function of x plus a constant 5 times another function of x. I'm going to compartmentalize my thinking. And I'm just going to think about the derivative of x to the 5/2 power. That's 5/2 times x to the 5/2 minus 1. Maybe do a little scratch if you want. I'm going to just leave it like that, 5/2 minus 1. And then say, oh, 1 is 2/2. But you don't have to do your scratch right in the problem. Plus, right, now I get to think about what the derivative of 5 times x to the minus 1/2 power will be? That's going to be 5 times the derivative of x to the minus 1/2 power. Using power rule, bring that exponent down in front, x to the minus 1/2 minus 1 power. To subtract fractions, I need a common denominator. And done, but we just need to clean this up. Five halves times x to the 5 halves minus 2 halves is 3 halves, plus 5 times minus a half. I think I'll write that as minus 5 halves. So plus a minus is minus. Minus 5 halves. X to the minus a half minus 2 halves is minus 3 halves power. And that's beautiful and pretty darn clean. You can do a variety of things here. You could choose to factor out your 5 halves. I think I'm just going to get rid of the negative exponents and the fractional exponents, but there's a variety of ways you could clean this algebra up. I think we're all probably a little rusty on fractional exponents, so just seeing that x to the 3 halves power is actually notation for the square root of x cubed. And 5 divided by 2 times x to the minus 3 halves power is 5 divided by 2 divided by x to the 3 halves power. Yeah. 5 times x, the square root of x cubed over 2 minus 5 all over 2. X to the 3 halves power is the square root of x cubed. That feels like a nice stopping point. You know, but this is fine. This is nice too. All right, so what was my strategy here? Was to use a little bit of algebra, right, to decompose this fraction into the sum of two fractions. And then just use laws of exponents. Just use laws of exponents so that I really am seeing I'm taking the derivative of a power function plus another power function. All right? Feel free to do this little scratch work off to the side. All right? Excellent.